In this one, let's take a look at a simple motivation for the rational roots theorem. So imagine this situation that you have, for example, you've solved a quadratic equation and you get these results that x equals, as an example, 2/3, and then x equals. So we're going to begin from the roots and we're going to rebuild the original equation so you can understand why the rational roots theorem says that the rational roots are always the ratio of the factors of the last term over the factors of the first term. That seems a little bit abstract. Let's work this out. So again, I'm beginning with the roots. Imagine you've solved the quadratic equation. These are the roots. You need to rebuild the quadratic equation from the roots. You can do that as follows. You can simply, in this one, since it says x equals 2/3, just multiply both sides by 3. It's going to give you over here 3x equals 2. And then you subtract 2 from both sides. So it gives you 3x minus 2 equals 0. And then this here becomes the first factor. Remember, when you solve a quadratic equation, you factor and you set the factors equal to 0. And then that gives you the roots. Now we're going the other way. So over here now, let me erase this stray mark so it doesn't get in the way. We have, again, I'm going to multiply both sides by 5. So that goes away. And I end up with 5x equals 4. Then I subtract 4. So I end up with 5x minus 4 equals 0. That 5x minus 4 is another factor. To rebuild the original equation, just multiply the factors together. So you basically take 3x minus 2, and you multiply that by 5x minus 4, so that equal to 0. So usually we're given a quadratic equation, and you get to what I'm calling step 5, correct? And you set each factor equal to 0, and you solve for the roots. So again, I begin with the roots, and I reconstructed the original equation at step 5. Now take a look. Here I'm going to multiply out, but when I multiply out, I don't want to just actually do the multiplications because I will miss an important piece of information. I want to pretend I'm kind of foiling. So 3x times 5x, so it becomes 3 times 5. So the 3 and the 5 are multiplied together, and then the x times the x is x squared. I've done it this way for a reason. Take a look. Look at these two values that you see here, the 3 and the 5. See this? The 3. That's the same as this 3 right here. Do you see? Go back at step 1. The 3 in the bottom of the 2/3 fraction. That's that 3, you see? Let's also do this for the other one. This 5 right here, that's this 5 from the bottom right here. See this? So now, let me go back and finish this up. Grab the orange color here. 3x times negative 4. It's going to give me negative 12x. Negative 2 times 5 here is negative 10x. Negative 2 times 4 is going to give me a positive. And again, I'm not going to do the multiplications. I'm just going to leave it as negative 2 times negative 4. The negatives give a positive. And then I end up with 2 times 4 in this position right here. Okay? So that's the 2 times the 4. Now, look back at the solutions at the first step. You see how that 2 right there in the top is this 2 right here in the last term? Do you see this? Look at the color coding. And then also, let me do that actually in light blue. Okay, so that light blue 2 at the first step in the numerator is this 2 right here. It's a factor of the last term at step 6. And then over here, this right here, that 4 in kind of yellow, it's this 4 right here. It's a factor of the last term. What this is showing us is a hint as to why the rational roots theorem works, which is the following, that just as this shows, you see that the roots, 2/3 and 4/5, in the top of the roots you have factors of the last term, the 2 and the 4. The 2 is blue, the 4 is kind of yellow. And then in the bottoms of the roots you have 3 and 5. The 3 is green and the 5 is purple, and those are factors of the leading term. So this is a kind of suggestion as to why the rational roots theorem works. You can extend this not just to, for example, x squared, but like x cubed, x to the 4th, x to the 5th, and so on. It's essentially that same logic that powers even more advanced versions of this. That's it for this one. Thanks so much for watching. I hope it's been helpful. I'll see you in another video.